Hello everyone, welcome back to my channel. So in this video we will see some of the previous gate problems on Cauchy's integral formula. Okay, Cauchy's integral formula only. So we'll see some gate problems. Okay, so until now we have solved some of the problems on this Cauchy's integral formula. Now we'll solve some gate previous problems. Right, we'll see the first question. So this question is asked in GATE 2009 for Electronics and Communication Engineering branch. So f of z is equal to c0 plus c1 z inverse. Then find integral a unit circle. So 1 plus f of z by z dz. Okay, so integral c 1 plus f of z by z dz can be written as integral c 1 plus f of z is c0 plus c1 z inverse divided by z dz. So z is equal to 0 is the singularity here. Okay, so the contour given is unit circle. So contour given is unit circle, that is mod z is equal to 1. So mod z minus 1, 0, substitute, if you substitute 0, so you'll get 0 minus 1, which is minus 1, which is less than 0. So it is inside the given contour. Okay, so inside the given contour only. So we can apply the Cauchy's integral formula. So what is Cauchy's integral formula for a simple pole? This is a simple singularity. So simple pole, so it will be f of z by z minus z naught dz is equal to 2 pi I into f of z naught. Here z naught value is 0. Okay, and f of z is 1 plus c naught plus c1 z inverse. Okay, so just substituting f of 0, so that is f of z naught, so you'll get 1 plus c naught plus c1 into 0. c1 into 0, because substituting z is equal to 0, so you'll get 0. So it will be 1 plus c0, because c1 into 0 is 0. 1 plus c0 you'll get. So this is value of f of 0. So this is 2 pi I into f of 0, but f of 0 we have obtained it as 1 plus c0. So it will be 2 pi I into 1 plus c0. Okay, so this is the final answer. This is what he has asked. This total is f of z divided by z. So if you substitute, you'll get like this. So option D is correct. Okay, so very simple problem, but it is asked in GATE 2009. Okay, so we'll see the next problem. So this is asked in GATE 2012 for ECE branch. Okay, so he has given f of z like this and closed contour this, and he has asked to find the value of 1 by 2 pi I integral c f of z dz. Okay, so he has given f of z as 1 by z plus 1 minus 2 by z plus 3. Okay, so just solving this, taking LCM, so it will be z plus 3 minus 2 into z plus 1 divided by z plus 1 into z plus 3, taking just LCM, so multiplying this with this and this with this. Okay, so z plus 3 minus 2z minus 2 divided by z plus 1 into z plus 3, so it will be z minus 2z is minus z, 3 minus 2 is plus 1, minus z plus 1 divided by z plus 1 into z plus 3. So the singularities here are z is equal to minus 1 and z is equal to minus 3. Okay, so z is equal to minus 1 and z is equal to 3. So the given contour is modulus of z plus 1 minus 1. Okay, so if you have z is equal to minus 1, so what will be minus 1 plus 1 minus 1. So this is 0 minus 1, so this is minus 1, it is less than 0. So z is equal to minus 1 is inside. Similarly, z is equal to minus 3 if you take, so it will be minus 3 plus 1 minus 1. So minus 3 plus 1 is modulus of minus 2, minus the modulus of minus 2 is 2, 2 minus 1 is equal to 1 is greater than 0. So this is outside the contour. So first of all, if you are given with f of z, first of all you have to see which singularity is inside and which singularity is outside the contour. That is the first thing which I have told you. Okay, so this is what you have to check first. So we have got one singularity inside and other singularity outside this contour. Therefore what you have to do is we have to, so integral C f of z dz, okay, is equal to integral C, so f of z is minus z plus 1, and since only z is equal to minus 1 is inside, so we have to shift this z is equal to minus 3 to numerator. Okay, so shifting this numerator, so this is f of z. Okay, let me write f of z first, z plus 1 dz. Okay, since this is lying outside the contour, you have to shift this to numerator. Okay, so we have to shift this to numerator so that only this is present, then only we can apply the Cauchy's integral formula. So integral C minus, we have seen already this type of problem, z plus 3 divided by z plus 1 dz. Now this total will become f of z. This total will become f of z. And now this is inside the contour, and we can apply the Cauchy's integral formula. What is Cauchy's integral formula? F of z by z minus z naught dz is equal to 2 pi I into f of z naught. Okay, so this is equal to 2 pi I into f of minus 1. 2 pi I into f of minus 1. So what is f of z? F of z value is minus z plus 1 divided by z plus 3. Now we need f of minus 1. Just substitute z is equal to minus 1 here. So minus of minus 1 plus 1 divided by minus 1 plus 3. So it will be 2 by 2, which is equal to 1. 2 by 2 is equal to 1. So it will be 2 pi I into 1. So it is equal to 2 pi I. Okay, but you are not asked to find this, you are asked to find 1 by 2 pi of this. So multiplying with 1 by 2 pi I on both sides, 1 by 2 pi I integral f of z by z, okay, so f of z dz, okay, is equal to, so integral C f of z dz, we have got it as 2 pi I. Okay, so 1 by 2 pi I into 2 pi I. Okay, so we are multiplying both sides with 2 pi I, because we have got integral C f of z dz is equal to 1 by 2 pi, sorry, 2 pi I. Okay, and we are multiplying here 1 by 2 pi I. I am multiplying this side also with 1 by 2 pi I. So this and this gets cancelled. So final answer will be 1. So the option is option C. Okay, so this is how we can solve the given question. Right, we will see one more question on the same concept. So this is somewhat typical question. Okay, so we have to solve it in different way. So let us solve it. Okay, this question is asked in GATE 2015 for electronics and communication branch. If C denotes the counterclockwise unit circle, then the value of the integral 1 by 2 pi I closed contour C real part of z dz is, okay. Right, it is of numerical answer type question, so you have to write the answer here. You are supposed to write the answer. So we know that z is equal to x plus iy in Cartesian form, and z is equal to r into e power I theta in polar form. So here he has given unit circle. So unit circle, then radius is equal to 1. Okay, so then z is equal to e power I theta. Then z becomes e power I theta. So he has given real part of z. Real part of z is x. Yes or no? So real part of z is x, and we know the relation between polar form and Cartesian form. So x is equal to r cos theta, y is equal to r sin theta, and since it is a unit circle, because the given contour is unit circle, so r is equal to 1, then real part of z, which is r cos x, which is r cos theta, but r is equal to 1, so now it becomes cos theta. Okay, so it becomes cos theta, right? So taking all this into consideration, I am considering this as I, okay, integral as I, right? So 1 by 2 pi I integral C real part of z dz. So 1 by 2 pi I, okay, So the closed contour will be like this. This is unit circle. Okay, so this is unit circle in counterclockwise direction, so it will be like this, counterclockwise direction. This is the circle of this is the unit circle of radius 1. So here it is -1, and here it is 1, here it is -1 again. Okay, so when you are taking unit circle as contour and you are converting it into polar form, theta will be between 0 to 2 pi, because it is covering all the 4 quadrants. It is covering all the 4 quadrants, so theta value will be from 0 to 2 pi. Okay, so if you are evaluating this integral, so substituting the limits as 0 to 2 pi. Right, so real part of z we have now found it as cos theta. So cos theta, and z is equal to e power I theta. So when z is equal to e power I theta, then what will be dz? Dz value is I e power I theta into I d theta. Okay, so I into e power I theta d theta. We know that e power I theta is again cos theta plus I sin theta. So just substituting this, what you'll get? 1 by 2 pi I. Okay, so this I is a constant, you can write outside because it is not depending on theta. So I by 2 pi I integral theta is equal to 0 to 2 pi cos theta into this e power I theta. I am writing like this, cos theta plus I sin theta d theta. So this I and this I gets cancelled, so it will be 1 by 2 pi integral theta is equal to 0 to 2 pi. So cos theta into cos theta, cos square theta. Cos square theta can be written as 1 plus cos 2 theta by 2. 1 plus cos 2 theta by 2 plus I into this will be sin theta cos theta, sin theta cos theta. So I am multiplying with 2 sin theta cos theta and dividing it with 2. So total d theta. Okay, so here there is a 2 okay in the denominator and there is 2 in the denominator, so I am taking this total 2 in the denominator outside the integration. So this becomes 1 by 4 pi integral theta to theta is equal to 0 to 2 pi. So what you will have? 1 plus cos 2 theta plus I sin 2 theta d theta. Okay, so this is what you have, right? So this can be written as 1 by 4 pi into integral theta is equal to 0 to 2 pi 1 d theta plus integral theta is equal to 0 to 2 pi cos 2 theta d theta plus I into integral theta is equal to 0 to 2 pi sin 2 theta d theta. Okay, right, so 1 by 4 pi into, so 1 d theta is theta, limits are from 0 to 2 pi plus, so cos 2 theta is integral of cos 2 theta is sin 2 theta, limits are from 0 to 2 pi plus I into integral of sin 2 theta is minus cos 2 theta, of course by 2 will have, limits are from 0 to 2 pi. Okay, so 1 by 4 pi into this is 2 pi plus, so if you substitute the limits it will be sin 4 pi, sin 4 pi is 0, and similarly if you substitute the lower limit it will be sin 0, which is also equal to 0. So 0 minus 0 by 2, which is also equal to 0, plus I into cos 4 pi, cos 4 pi is minus 1 whole square, so is equal to 1. Cos 4 pi is minus 1 whole square, which is equal to 1, and cos 0 is 1, so 1 minus 1 is again 0, so this also becomes I into 0. So this is 0 and this is 0, so you'll get 2 pi by 4 pi, which is equal to 1 by 2. Okay, so this is the answer here. So answer is 0.5. Okay, so this is how we can solve this type of problems. If you are given with real part of z or imaginary part of z, you have to take the relation between Cartesian form and polar form like this, and then you have to solve the integral like this. Okay.